Wait for another minute. Okay, let's start the meeting. A very happy new year to everyone. I don't know if everyone's back from the break yet, so might have a thinner audience today, but hoping for a very I don't know, productive new year for everyone in their personal lives, professional lives, and for the OCP too. So with that, let's get started. We've got David and James scheduled to talk for, I think, about 10 minutes each to start with. So we'll go there, and then after which we want to talk a little bit about the Chiplet Summit. I think Cliff should join by then. And we've got a reasonable idea of what the agenda looks like for the OCP tutorial session, which is on the Tuesday afternoon, which is the 21st of January afternoon. We've got some panels and some talks, and just wanted to go through it to make sure everybody knows what time and where, what their role is. So we'll do that in the second half of today's meeting. So that being said, David,
right.
it's going to be all yours.
Okay. Thank you, Anu. Happy New Year to everyone. Is my slide visible?
Yes, it is.
Yep.
Okay. So today, to start off the new year, Happy New Year to everyone. So to start off the new year, we have a couple of things that we have been working on last year, and we are ready to contribute. So the first one that I'm going to talk about is the test design kit, Chiplet test design kit. First, I wanted to start with the obligatory introduction to CDX and really focus on our charter. And we are chartered to work on standardizing chiplet models, workflows, and ecosystems. So the focus of this contribution focuses specifically on the models part. This is something that we have been working on last year. Let me actually start and talk a little bit about the test design kit. It's just one of the pieces of the 3DK. It's the 3DIC design kit. TDK focuses on carrying DFT-related data. It's an extension to the existing CDXML format that we contributed some time back. So this is an addition to that format. One of the things that the test design kit does not do, some of the things that it doesn't do is, first of all, it doesn't focus on a specific workflow or methodology. It doesn't recommend that. That would be part of the test workstream that was formed late last year. And it also does not specify any new DFT methods or techniques. Really, it's independent of those. it's really only meant to carry some of the data that's necessary to implement tests. The test design kits does not focus on any specific test protocols or methodologies. It only carries the data that a designer would need to implement a DFT for their chiplets. There are several parts to the test design kits. The way we looked at it, there is really three pieces to test. One is the physical description. That is what kind of bump pads we have. And that came necessary once we started talking about sacrificial pads and pillars of different sizes for different portions of the die and so on. So we needed to provide a description, physical description of what the pads and bumps are. The other piece of the test design kit is a description of the logical pin assignment. Really, what we are capturing in that section are what are the different test modes that a chiplet will have, and how are pins being used under different test modes. In the follow-up slides, I have a little bit more of the description for each one of these. This is just a high level. And last but not least is the workflow. When we worked on the test design kit, one thing we realized is that the data will be changing throughout the flow. And most of the cases, it will be improving and it will be enhanced. And second thing is the different uses of the test definitions depending on where you are. For example, if you are in manufacturing and you want to do wafer level test, you want to know where the sacrificial paths are because that's what you will be probing. Once you ship a final product, a chiplet, those sacrificial paths will not be accessible. So they don't need to be defined. However, you still need to define any test pins which you want to expose to your customer. So data is changing throughout the flow, so the file format needs to accommodate that in a fairly straightforward manner. So diving into the different pieces, on the physical description, we have captured 4 different types of excuse me, I'm not sure how to best describe this with one word, but right, you will have the in cases where you have bowls, right? You may have a BGA bowl type bowl, which is basically a singular spherical shape. You may have a pillar, which will be formed by multiple layers of the positions and may or may not have a solder cap. Then we have the unbumped pads. Those typically will be sacrificial pads. They will not be bumped. There will be no pillars. And those would be used for wafer level probing. Those unbumped pads are actually different than hybrid bump pads in the sense that typically the unbumped pads may have multiple layers and they will not be fully flat. Hybrid bond pads, on the other hand, will be just copper and it's supposed to be fully flat so that it can bond to the next level silicon.
Hey, one quick question for you, David.
Yes, go
This
ahead, please.
description of the pad, that's just the location, right? Because for test, it doesn't need anything more than where it's located and what it's called.
For test, it is just the locations. That's really what you need. But really, apart from locations, what you need to know is what is at that location, right? If it's we need to distinguish between sacrificial paths and actually bumped paths.
Right. Agreed.
Right.
Agreed. You need to have a description as to whether it's a sacrificial pad or it's an actual scan pad, TDI or whatever it is.
Correct. So the
Okay.
so we right the way it works is you will have a test tag on the logical pin, and then you'll have the physical description of that pin. From the two, one can derive where are the sacrificial paths that need to be probed at wafer level. And then when you're shipping the final product, you can scrub those sacrificial paths from the definitions and ship only the bump pad locations.
Right. Yeah. It's only an intermediate step for wafer probe.
Right. Yeah. Um, yeah. The difference is really that the data kind of splits. When it goes to manufacturing, you have you derive the sacrificial paths when you ship the final product. You really don't have to define the sacrificial paths unless you want to let your customer test your dies. Right.
Right.
Again, that's a workflow type of a question. And we wanted to stay flexible and to allow that.
Okay. I, I would, have you talked to Rajesh about this work? Because I just want to make
Yes,
sure that, okay, great.
yes, he was part of the team
Perfect.
that worked on this.
Thank you.
And really, the description that there's two types. One is the 2D description, the dimensions, something that you would need to do layout and routing, stuff like that. The 3D part actually comes in handy once you start doing mechanical simulations and or thermal simulations, or even for electrical simulations, you want to know what is the actual construction. And as part of that, the TDK will also reference the materials, which will be part of the MDK that James will cover
Okay,
shortly.
sounds good. Thank you.
Okay, on the logical definitions, really what we strive for to be able to define is the thinking was an engineer would look at at the design in the beginning and basically figure out, okay, here's my test molds, and for the different molds, here's how I'm going to assign my test pins, and it typically looks at a little bit like a table that you have the different pin assignments for different molds. So the definitions capture that what which pins are used in which test molds, if they're used. It captures how they're used at pretty basic level. Captures clock and data in and data out. And again, there's a definition whether that pin is a test only, right? In cases for sacrificial paths, which are in case it or even test only pin by itself, right? Even if it's bumped, we can handle that and say, hey, this is a test only pin. So the final product may want to scrub that pin from the definition, right? If you don't want to allow your customers to fiddle with the test pins. And we also have the tags for sacrificial paths so that it's clear which pad and shape is a sacrificial paths, and it needs to be dealt with properly in the flow. And the last pin, and the last part of this is the workflow part of this. We don't recommend it, a specific workflow, just wanted to make that clear. But really, the definition of the CDXML needs to be sensitive that different parts of the workflow would deal with the data differently or would be enhancing the data. Couple of examples, right? When you are just planning the pin assignment, you really don't need to think about the physicalities of those pins and pads, so you don't have to define them. You can do the actual definition at a later stage once you figure out what the manufacturing is going to look like, especially the 3D part. So the file format is meant to be input and output, where a tool, an EDA tool, would read it in, a user would modify it, and a new file will be generated out of this. And again, right at the end of the day, there's the I keep repeating myself, but I wanted to emphasize that again, that different parts of the flow, especially manufacturing, would look at different pieces of the data, and the final product does not really have to have all the sacrificial paths definition and things like that. We are not enforcing in this file format. We are not enforcing any requirements in terms of what has to be defined at which stage. Really, this is a file extension meant to enable the different workflows and tools. Couple of examples that I wanted to show you is this is a quick definition of a test mode, what it would look like. Really, what you would the way it works is if the test mode is externally controlled pins, it would say this is a test mode, it's external, and it would define in what external pins, in what state they need to be to put the chiplet into that test mode. If it's internal, there won't be any specific pin definitions. This was also meant to cover a low pin test count modes, cases where just a singular pin will control test mode. So we can handle that as well. We consider that. Another example of a
Good time, sir.
sacrificial, yeah, I'm on my last slide. Just an example of what a sacrificial path would look like. And we just define it, it's sacrificial. We just add this tag, and that's about it. To summarize, you can find the draft version at this link. And again, we are meeting Thursdays at 10 a.m. Pacific. And if this is of interest to you, please come by and join us and contribute to the CDX work. Thank you.
Thank you, David. And now James will talk about the material design kit.
Okay, yeah, thanks, Anu and David. So I'm going to start. How much time do I have?
I think 11 minutes. I'd like to switch modes at 8:30, but if you go a minute or two extra, I think we can live with it. So
Okay, all right, I try my best. Yeah, I think it's yeah, Happy New Year to everyone. Yeah, again, thanks for David for the intro. We some of you probably have seen some part of this. We presented in the global summit. So this is kind of more extension to it. We have some changes or finalize some of the structures. So including extending to some optical properties. So and also like the make it more clear. I think I organize structure that way. So just want to focusing on introducing on that. So it's really thanks. I think I list of the people here that contributed to this works here. So and let's start with the this 3DK. So I think probably I think they will probably introduce or in talk before. So this is under the big umbrella. The MTK here is is part of the 3DK. I brought up there, want to highlight again this one, MTK, I think used for materials in many places, mainly focus on the architectures way, the packaging planning that's highlighted here. And then in the analysis that you use here, for the performance, thermals, and then using the sign off as well, or for the material analysis for the SIPI and as well as thermal and mechanical. And as they mentioned, I think definitely I think part of the design, I think I can be used some material here and there. I think it depends on the specific of the design. So for the intro, the MTK is already, I think I want to standardize and streamline the chiplet-based design. We all know material is a very crucial, I think when designing a chip and also a chiplet. So it's provide like framework for defining, evaluating, and validating material properties and also design parameters. Here we mainly focus all the core components such as the diode, substrate, interposer, RDL, and the 3D IC. So, and is really emphasize a lot like materials that has impact on the performance, reliability, and also as well as the cost. Um, Also want to highlight here, this is the joint effort between the OCP and the JEDEC. So part of work there like will be published in the JEDEC as well, as we have been doing for some other works. So as mentioned before, so do we have the key component here? I'm going to just kind of skip to here. I think you all probably familiar. I think all this kind of key component in the chip design. Um, and just I think all these component has the materials like required, right? For example, the tile you will probably need to like the foundation of the tile, right? I think like the what other component build up the tile? I think like the silicons, like the uh, some of dice probably also I think I have all this kind of like the material that's make up of the those kind of bumps and everything. So same thing for the packaging as well. They like substrate involved. Interposer you have like all this kind of connectivity like the wiring. And then the RDL definitely I think is the layer on top of the wire on top of your the chip design, and then the 3D involve all those kind of via and stacking, etc. Um, yeah, key components. I think high level structure wise, I think we have like electrical focus, kind of like material related properties. We will dive in more in details on this. It's just kind of like a high levels to show you. I think like for like to get an idea, I think like electrical definitely. I think like there are DF, DK, conductivity, like resistivity, and then you have like the thermal. That's another big important part where it's all where it depends on the material that you use. And then you have a structure. So right, the young modulus, the poisons, CTE, they all have impact like how strong and the stress and strain like on different environment, which is very important. Like for example, automotive things are constantly like shaking and moving, and you want to make sure that you have a very like either elastic or like very like strong structure that can withstand those kind of environment. And then you have like the optical. I think that's something that we like adding a new one. And then we have like two other important one to highlight here. I think we didn't emphasize a lot. One is like the measurement condition, which is like every parameters that you provide here, they're not constants, meaning like not constant at it's only constant as a particular condition. That's what we want to emphasize here. So when we provide some parameter, for example, like DF, DK, like some number like 10 or something, like it's at the room temperature, that's the number. But then you have like higher temperature, like let's say like the 10 degrees over room temperature, the number might be changing. So when you do this kind of measurements and we do this kind of like the analysis, then it's very important to know like what kind of condition that number it should be used. And I think definitely important is like units. So like we've seen a lot of different units and different formula is different really like people have been using. So like every like manufacturer they have um choose a certain kind. I think like the like depends. I think like the area of the focus. With either do like the analysis or they do more kind of performance comparisons. Like they always kind of might not be using like the same like units, but then they can be convert and equal in some way. So let's dive into these electrical properties. So as mentioned earlier, so we have a DK, DF. So we structure in a way such that like, we define what are they. I think this all very well known. I think what are the DK, so the ability like material to store electrical energy. And then you have like the DF. Sorry, anyone have any questions? Um, all right. So and then we are highlight here is the unit and also the condition. So that there's some doesn't have a unit. And then you condition, you have to specify like temperatures, and then you have to specify the frequency here. So, and then same for the resistivities and then conductivity, also like the relative permeability. I think these are the common 5 properties that used in the electrical related material properties. And then next one, we have the thermal properties. So the thermal conductivity, I think this is definitely works for Kelvin. We can't debate a lot. I think this is probably one of the more common units we're using. So it's just how material to conduct the heat. This is probably used one of the most one when we do the heat dissipation. This is like always the one that's coming up. And then you have the a specific heat that heat required to raise the temperature. So that is you can see here that's kind of use slightly different unit here. On proof you use a Kelvin, here you have Celsius. So that's why I think that is very emphasized, very important. It depends on very kind of different kind of physics. When group of people when defining on that, I think typically they have from different background define this kind of phenomena of the physics. So I think I tend to be unified different there. So and then that one is just like the densities of the material that's impact the unit as well. Also the impact on the thermal properties as well. All right, the next one is like the structural. I think typically you have about this the Young modulus, which measuring the stiffness, measuring the Pascal, and then your Poisson ratios, that traversal to axial strength. I think that is a uniqueness. So they both very sensitive to temperature and also to the orientation as well. Right, so depends on where how you put them, position them. Other thing is like the failure properties. So I think it's very important. I think I want to see how phase out of the material can handle. They're all both in Pascal, and then one is in the yield strength, and then one is a phase out strength. I think it's like the combination, I think between thermal and also the mechanical, which is the very commonly used CTE. So which is change because it's combination because this is very interesting measuring. I think since the thermal temperature is not constant, you want to see how materials changing, mechanical condition are changing in the various temperature. I think that is where this is very commonly used. I think as mentioned earlier, the optical properties. So we're trying to introduce here, which I think the optical I think become more and more common. That's going to add it here. One is the refractive indexes, so measure the light bending to it. So all this about the wavelength, and then the other one is a reflectance, so proportion of the light reflected from the surface. So it's something have to do with the angle as well. And then there's the transmission, so the proportion of the light transmitted to the material. And then roughly is another combination between the surface and also mechanical. So which is the phase roughness typically has the impact, the texture that you use, the surface roughness. I think have some kind of impact on when you do a stacking and things like that. Have impact on the how the interaction between your surfaces. And then you have another tensile strength, so kind of how resistant into the cracking under the tension. And then you have transition temperature, so where temperature which material tends to be a change different phases like the graph temperatures. So if somebody have questions, okay, maybe not. So yeah, I think that's all about the properties. And we as mentioned before, we have two kind of demo or the example here. One is the the OCP demo example, David and the group has been working on. So they share some of the graph subsets, and also dielectric material here. So like we have the XML file that created using the XML schema based on the structure. So put up the link here. I think I will share this, and then if in the document, if anyone interested can take a look. Another example is like shared by the ASE, which is like the example that typically they use for to doing the role like packaging and also material properties analysis. So we can accommodate this data as well within the structure that we have created to the XML schema. So that's the last slide. The draft paper, I think I can be viewed here, the link. And then there's a GitHub where we store all these like examples, data, and then there's a schema as well will be part of the link for the XML. We have meetings like every other Thursday at the 9 a.m. Pacific time. That's all from my side. Thank you.
Thank you, James. So one quick question for you, and I might have missed this. We started talking about the material design kit, but we also went through a whole bunch of structural, thermomechanical.
Yeah.
Does the material design kit include those, or those are part of other, like optical properties and things like that?
Oh yeah, material design kits will include all these properties. So it will, as part of the structure, it will describe all this information. I can quickly open up that the schema. I think I just for reference.
Okay, so the material design kit has okay, so I see that. I see you've got electrical. So this is all part of the material.
Yes, they all
structural failure,
right.
Thermomechanical, optical. I see. Okay. Thank you.
Sure.
Any other questions for James? Thank you, James. Thank you, David, for presenting.
Yeah, thank you.
Thank you.
Now the next topic on the agenda was the Chiplet Summit, and we have Cliff. Yes, we have Cliff. Here you go, Cliff, all yours.
Hi, Anu. Hi, everybody. Happy New Year. Thanks for joining. Anu, are there specific questions, or did you want me to just provide a little bit of an overview of what we're doing?
Yeah, let's do the overview first, Cliff, and I'm hoping that there will be some feedback or any questions we can answer. Not everyone who is presenting is here today. I think I will have to send out an email to a few folks who typically don't join our meetings, but are speakers on panels and things. So I will do that later today to make sure they're aware of the, what they're supposed to do when that happens. But for everybody else who has been kind enough to attend today, I'd like if you can go through the schedule.
Yeah, absolutely. And so at a high level, I think everyone's aware we've been an important or large sponsor of the Chiplet Summit since its inception. And this year's no different. We have worked with the organizers to get permission to organize a tutorial. The tutorial will be on the first day of the summit, which is the 21st in the afternoon from 1 to 5. And in addition to that, and anyone that registers for the tutorial using the link that we've sent out to everybody gets complimentary registration for the entire event. So please use that link as part of our community to get registration, complimentary registration for the event, and please do attend our tutorial. On top of that, we will have a booth, and so the OCP team will be on site. In our booth, we're going to have a small innovation village, some pre-commercial demos that our nonprofit partners will be showing. We'll also have an OCP ORV3 rack for those of you that would like to see one and haven't had a chance yet. And of course, the team will be there in the booth to talk and answer questions and get any feedback you might have. Also, there is a keynote that's going to be on the second day of the conference in the morning, and I believe, Anu, that's one that you're doing. And so OCP will be well represented at the event. And I'm going to share my screen. There is a question about the link, the registration link. We can try to pop it in the chat. I can check for it. It did go out to everyone that's on the Groups.io mailing list. So you should have seen it. And but if you haven't, you can also email me directly and I'll send you the link if you're still looking for it. There will be some more communications coming out with the link. So please watch for that.
Hey, Clifford.
Yeah.
I think Anshu is asking the same question that I was going to ask. I went through that link that Anu sent out and you sent out, and I registered. I got to a page which says, yes, you're registered. Thanks for registering. But I have not received any confirmation or tracking number. Should I be concerned about it in the sense that I don't want to go there and say, hey, I'm not sure you're registered or not. So I didn't get any confirmation email with some confirmation number.
Okay.
Yeah, I don't think any of us did, Raghu. I think Jawad actually mentioned the same thing some point to me. So
Okay.
We can double check with the conference organizers. We will probably have a call with them before the event. It is, sorry, they gave us the link, so it's their registration system this year that is doing that. But we can double check to see if there should be an email expected or not, and we can also double check the registrant list. So give us some
Right.
time, we'll follow up on that. But let's assume everything's okay for now.
Okay, thank you, Clifford.
Yeah. Okay, so I'm just sharing my screen because this is the plan for the afternoon tutorial. So it's going to be on January 21st from 1 to 5 p.m. That's a Tuesday. And we're going to have it kicked off by Anu, doing us the courtesy of doing a keynote on the open chiplet economy and an update as to where we are on many of the projects for everybody. And then we're going to spend some time talking about the different tools for the open chiplet economy that are in the works. So Shahab has agreed to talk about the die-to-die phi comparison or metrics that we've developed as a community. We have Steve and Raghu agreed to talk about the business analysis work that's been going on in the community. We've also got David and James giving another update on the 3D design kits for the community. And then we drop into some work that looks at, how we impact some of the use cases around edge and AI. So we'll have Sri Ganesan talking to us about generative AI and some of the work, and that presentation will be an update from what was done for Global Summit. We've got Matmehita and Rajesh talking about SIP-based testing, system and package testing challenges and how to solve those. We'll also have an update as to where we are on the different bunch of wires 2.1 interfaces that are coming along. And then John Shaft has agreed to do a talk on the modularity work being going on in the modularity workstream, looking at modularity for HPC and AI. We do have an invited talk that came in from the conference organizers on databases for managing chiplet IP. And that's going to be done by someone who's new to our community, Simon Butler. And then we've asked Jawad, and Jawad may invite another speaker or two to talk about the concept of abundance of wires. And if we look forward into the future 5 years, what could a die-to-die interface look like that has allows many interconnections, almost as if we're connecting two dies without needing to go to a smaller form factor for the interconnect and going to packets. And then we'll finish it off with a panel session. DJ from Meta has graciously agreed to moderate that session. So we will go forward with that for the panel. So I'll stop there. I think Anna was wanting to open it up for a bit of discussion at this point.
Yes, so thank you, Cliff. So everyone who's on the call today and your name shows up in the speaker list in column H, I hope you already know that you've been recruited for this. Rajesh, if you could reach out to Madhumita from Sina. Is Rajesh on the call? Let me check.
Yeah, I'm here.
Oh, perfect. If you could reach out to Madhumita and make sure she's aware of it.
Yeah, I
Everyone
understand.
else who's not on the call today, I'm going to do a special email just to make sure they're aware and they've not forgotten and it's not fallen off the calendar somehow. Any questions from those who are on the list
Hey,
too?
one question I have, Anu.
Yeah.
Do we need to follow the Chiplet Summit PowerPoint format? I received it through their organizers.
Yeah, thank you for the question. Actually, I'm about to send out a template to everybody. We did use our own template last year, and we're going to do the same this year. Reason being is we would we're going to post all the presentations at the OCP website afterwards. Unfortunately, it's not recorded, so we'll not be able to have recordings as we typically do, but at least we can put the presentations available in the public.
Okay. Okay, so we will not be using the one we used in October when we did for the OCP. We had one PowerPoint format for OCP Global Summit, but we're going to get a new template from you, Cliff, right? That we can, it might be something joined between you and Chiplet Summit, I presume, right? So it'll be a different template.
Correct.
Okay, all right, we'll wait for that so that we will have to just transcribe our content from the Global Summit version to this version, new version.
Thank you.
Okay.
And hopefully, if there's any updates you could provide some fresh content, that would be great.
Oh yeah, no, thanks. Yeah, I will definitely do that. Thank you.
So Cliff, would you be able to email it to everyone who on this list who's not on a panel? Or I
Yes.
can forward it to the folks who don't usually attend this call, but who are giving talks.
I was going to send it out to them
Excellent.
directly, so I can take
Yeah.
care of that.
That also serves as a gentle reminder that they have to get their stuff ready sooner than later. So that's very helpful. I appreciate that.
Yeah.
The one question I had, and this is something that Javad actually brought up on a call we had earlier this morning. It was the line item 21. The abundance of wires. Now that's a concept that came up with the NAPMP release. It hadn't gained the kind of momentum it has since then. And he thought it would be good to bring it up and discuss, and I think it's an excellent idea. In fact, I would at this point I'm kind of excited enough to say we should make a panel of it, but you're not going to screw around with the current program or Cliff will kill me. So, but I just wanted to ask folks what they thought about it and if it makes sense to talk about it. It is a new concept. It's somewhat contrary to what people have been doing for a while. So, is it something that makes organizations happy? Possibly not, but it seems to be the way at least the government is thinking. And just wanted to get any opinions here today that'll help Javad and me to see what it should be about. But I thought it was a great idea that he came up with. So anyone wants to say anything, feel free to chime in. Ash,
I
come
would
on.
just say, yeah, I would just say that I'm not sure what the government's doing actually makes any sense, but that's a different subject. There is definitely with hybrid bonding, effectively, you can put your phi, if you want to, in inverted commas, anywhere on the die, right? It's no longer an edge issue. And if you look at, the other standard like UCI 3D, which is obviously from Intel, they have expanded on that. So I think that when you get to sub 10 micron pitch, wiring stops being your problem. And as Cliff said, you may not need all this serialization. So UCI 3D doesn't have any serialization, right? It's just running at the core clock. You get 10 times lower power. A lot of good things happen. So it's clearly the way the market's going to go, right? Long term for high performance, where you eliminate the number of wires as being your problem. So I think it's good that we're talking about it. So in a roundabout way.
Thank you, Kash. Appreciate the feedback. Anyone else?
Hey, Anu, this is Kevin. Happy
Hey,
New Year.
Kevin.
I'm a little confused about what your point is. I agree with everything Kosh said. I already see, the abundance of wires slot available to talk about exactly, the potential future world. What do you want to add to this agenda? I'm not getting it.
So I wasn't looking to add, but since we've introduced this new topic of imagine a world with an abundance of wires, it has never been visited before. It came into prominence thanks to the NAPMP. All along, we've talked about, for HPC systems to increase the data rate of the data we send on the parallel interfaces that have existed so far, including the BOW, the UCIe. But now the abundance of wires goes in a slightly different direction where it says reduce the data rate, but put as many wires as possible on an edge. So I just wanted to, we wanted to talk about how that's somewhat different from traditional thinking and what it means to the industry and what it means to existing ideas and interfaces. So it wasn't to change anything, Kevin. It was just to bring it up as an interesting topic because it is relevant today. I mean, all the NAPMP proposals that went out had to talk about abundance of wires or you're not going to make it. So what does that mean to the industry? Because it's a change in direction.
I guess
that was my thought.
I disagree with that assertion. I think it is a different time frame than the direction of, higher speed edge based, like Kosh said. It's much further out in time, abundance of wires. So I see them as complementary, not as different directions, but it doesn't matter. Anyways, I think Kosh, I would really hope that we talk about this in the BOW 2.1 section for sure. And so I think what you're saying, Anu, is you'd like to see some of the these concepts worked into the other talks that are here. I think 3DK supports can support it, and BOW 2.1 can certainly support it. So I think it would be good to get that theme brought into here, into talks where it is relevant and makes sense.
Yeah, and again, I completely agree with you, Kevin. The thing is, forgetting NAPMP or whatever that group is, the Devendra Shah, whatever his name is, that Intel had already they already published a paper, I think, in 23 that I saw that was public in early 24, where they talked about, what they were doing, and that subsequently has become UCI 3D. So it is running at 4 or 5 gig, right? It's not running at 64 gig, right? It is a lower frequency. There is no serialization. It's all the things that NAPM talk about, except they don't specify how you build that connection, right? Whereas the UCIe guys have come up with something that, in my view, isn't great, but they have something, right? And as Kevin says, I think we within our group, the PHI group, I think we certainly will be talking about that. And maybe that's UCIe. I mean, that's both 3.0 or rather than 2.1, but that's a separate issue, right? I mean, that's something we'll need to address. And to your point, Kevin, this is not today. Intel or probably NVIDIA are probably going to use it internally, right? So, but in terms of general use, it's still a few years away, and so it is multiple years away. But it is already starting to be used in the industry. That's the reality of this. So
yep,
yeah,
I agree with all that.
I agree. Appreciate both of your feedback, Kevin and Kash, and maybe on the Wednesday call, Ilad's call, we can discuss it a little bit. It's relevant today because it's something that would see the light at the end of the tunnel maybe 5 years from now or even longer, which is again the time frame they're talking about. But
agree that it's relevant. Totally agree.
Right. Okay.
So-
Jawad, this was your idea. I hijacked it. I think it's a great idea. Do you have anything else to say?
No, I
Sorry
think
about that.
this is great. And it's absolutely right that temporally speaking, government even says that this idea belongs to 5 years down the line for national interest. So meanwhile, the commercial work that's going on for 5 years, I don't think we can change that. But it's more like giving everyone a North Star in the future.
Hey, Anu, this is John with Crossfire. I just want to throw my hat in the ring here. So I think that this is going to be more disruptive and quicker than we might imagine. And so I think it's something that we really want to keep an eye on and a watch on. I think the problem for the industry is it's very, very disruptive to some of the current work that's going on with all of the standards that base on very, very high speed chiplet to chiplet interfaces versus very, very wide and chip clock rate types of interfaces. And there are issues. We've been looking at this for a while, and honestly, we think it's the way to go.
Oh, yeah, no, that's an interesting perspective, John. And I think I tend to side with you where it is somewhat disruptive to what's going on today, but it might be the right answer down the line. Of course, this is not just the electrical portion. Everything has to move with it. Today that technology doesn't exist in mass production, and all of that has to happen in the next 5 years, which is quite easy to do given the rate at which changes have been happening in the packaging industry in the last few years. So we do have to keep an eye on it, and I think it was a great point that Jawad brought that up and introduced that into ours, because it makes sense that we keep up with what the changes are and see how we can incorporate it or influence it or do something in our own way through the OCP. So thank you, appreciate that.
Yeah, my pleasure.
I don't have anything else. If there are no other questions, we
Sorry,
can...
Anu. I was hoping, so Cliff, I want to go back to the OCP tutorial. So you're going to send out a template, which is great. Are there any deadlines? Material doesn't have to be sent in advance, I guess, because it's not posted live like OCP Global Summit. So there's no dates or deadlines that I'm aware of. Is that accurate?
That's a good question. So I think it's up to Anu and Jawad to understand, I guess, to take a look and see, did we want to collect the presentations and do a review in the next week or two? Is that the plan for the Friday meeting? That's an Anu and Jawad question as to how they want to handle that. Ultimately, we would like to have all the presentations shared with us so we can collate them and put them on the website at the OCP website.
Right. Okay, thanks.
Yeah, so that was something actually we were supposed to talk about and I forgot. So thank you, Kevin, for bringing it up. Ideally, we'd like to use the next 2 Fridays to go through material. I fully recognize if you're not 100% ready by next Friday, because we haven't given you much notice. But I also think that the material hasn't changed all that much from the global summit, other than the template and maybe a few slides. So I would suggest using the next 2 Fridays. We will cancel the meeting the week of Chiplet Summit, but that leaves us, I believe, two Fridays. And so I'll reach out to you guys if anyone has a presentation they'd like to go through as a practice review here on this forum. We would be happy to do that. So I'll send an email out with more dates and deadlines, but I definitely don't want to torture all of you starting the new year with, hey, have something done by next Friday. In whatever shape or state you are by next Friday, if you want to share it, that's great. But I think by the middle of the week after, is probably when you should be ready, but I don't have dates off the top of my head, but I'll talk to Javad and we'll send something out. As to, an absolute hard deadline, maybe a couple of days before the meeting, where we'd like to at least have, be able to collate the slides, as Cliff said, so he can put it on the website afterwards.
Sorry, Nick, do we need to, I'm along with Trent, I'm also on a session with, on Pre-Con A, Chiplet Basics. And I just want to check with y'all and Trent. I didn't see it in that agenda that you put up, Cliff. Is that a separate thing that I work with Trent on that?
Yes, I believe Trent is on the call, or he was.
Yeah, no, Trent is on the call. I mean, I saw him on the call.
Mm-hmm. Yeah, that is Tuesday morning. And so, yeah, I knew I kind of the same question. I know that you're focused on the Tuesday afternoon tutorials. The Tuesday morning is just a Chiplet Basics one, just like we did last year.
Was that a question for me, Trent?
No.
Okay.
Well, it was kind of, yes. Yeah, the question was, are you, I was wondering, why did you just choose the Tuesday afternoon tutorials? Is because you're organizing that one, right? But
yeah, this is the Tuesday afternoon is just completely an OCP session, the entire 4 hours. But I think the ones you are talking about are other sessions. For example, I'm trying to get our BoFi team on Letitia's tutorial on data interfaces. And so those are different from the OCP, but I believe if the question is if you are going to create slides for any of that, you would use this template that Cliff sends, because I'm assuming that you'd be representing the OCP there. So
oh yeah, that's my question. I mean,
Yeah.
besides the template, I just want to be sure that what Trent and I do. Trent, it looks like you and I will just have to sync up offline and see what I need to do for you.
I'm gonna sync up, because there's 4 of us, maybe 5 of us in that session, and so yeah, I plan to sync up offline. Regarding the template, there is one that I downloaded from the Chiplet Summit site under speaker resources.
Yeah.
Now, but when I download that one, I don't know, it's kind of weird. It's a 16 by 9, but it's not the wide format, right?
Yeah.
Or it looks like somebody tried to fit it into a 16 by 9 format. So it's not very good utilization of the page. Is that the same one you're going to send out, Cliff?
No. So we have control of our OCP sponsor tutorial, which is on the Tuesday afternoon.
Okay.
That's
gotcha.
all I could speak to. The other ones, that's with the Chiplet Summit organizer. Sorry.
Gotcha. All right.
Yeah, generally sessions outside the OCP one should use the Chiplet Summit template. That's what I've done in the past.
Yeah.
So
Yeah, I
that
was gonna
Tuesday morning and
yeah.
So Raghu, so that's the one we would use. And
Okay.
So I can
However,
that one.
you are welcome to put an OCP logo on your presentation that you're doing outside of the Tuesday afternoon OCP sponsored one. If it's work done at the OCP in the collaborative community, you're welcome to do that.
Mm-hmm. Okay.
Okay, no, I just like Trent, no, we can sync up offline. Since we are in the OCP forum now, I just wanted to be sure that the topic that you and I are covering along with a couple of other folks, I don't know if I just kind of wondering whether it comes as part of the OCP sponsored Pre-Con A or
not.
Okay. It's not okay. That's okay. I just wanted to check on that. Okay.
One last thing before, I know we're late, we're over time. Please be aware there was a call for papers that went out, closes February 10th for the EMEA Summit. So any of you that are in Europe want to come to Dublin and speak around chiplets, please put in a proposal. We'd like to have as much representation around chiplets as possible. We'll also be canvassing the EMEA parts of the community to put in proposals.
Thanks, Cliff. Are there any other questions, or we're a minute over? I
Is
see
there a
Bill on.
registration for this tutorial? I remember Clifford said that there's a free registration.
That's correct, William. Bill, there's a link from the OCP that if you use that, the registration is complimentary. And if anyone needs it, let us know. I think Anna's going to send it out again on the Groups IO channel.
Yeah, if you could send it out, that would be great. Thank you.
Okay.
Will do.
Great.
I'll send it out today to everyone, and have a wonderful weekend, and we will talk to you next week. Thank you very much, everyone. Bye.
Take care. Bye.
Thank you.
Bye-bye.
Right.